the world is facing an unprecedented environmental crisis. Every year, millions of tons of waste pollute our soils, rivers, and seas. In Montevideo, Uruguay, alone, more than 605,000 tons of waste were collected in 2023, a 6.7% increase from the previous year. Despite local efforts, recycling remains a small fraction of the total, highlighting the urgent need for more effective and sustainable solutions. One innovative alternative is waste gasification, a process that converts trash into liquid fuel. Unlike burning waste, this method does not emit harmful gases. For example, 1 ton of gasified waste could be transformed into an equivalent amount of fuel, which could power a highly efficient, multi-fuel engine like the MCR. This system not only reduces the volume of waste ending up in landfills, but also turns the trash problem into an opportunity to generate clean energy while extracting CO2 from the atmosphere, thus contributing to climate change mitigation. What was once considered worthless waste becomes a valuable resource. With just 1 liter of fuel produced from waste, this engine can generate around 3.8 kilowatt-hours of electricity. If we consider that a ton of gasified waste can generate approximately 1,000 liters of fuel, this translates to 3,800 kilowatt-hours of electricity per ton. If we scale this figure up to the 605,846 tons of waste generated in Montevideo in 2023, approximately 2,302 million kilowatt-hours of electricity could be produced. To put this into perspective, the average annual electricity consumption per household in Uruguay is about 3,200 kilowatt-hours. This means that, with the waste generated in just 1 year in Montevideo, we could power around 720,000 homes during that period, nearly half of the households in Uruguay. It is important to note that these values are estimated, as the MCR also incorporates advanced energy recovery methods, capturing energy released in the form of heat, increasing its efficiency and energy generation. Its integration into the electrical grid would not only reduce energy costs in one of the countries with the highest rates in the region, but also help address the waste problem, where currently trash is compacted and buried. In tests conducted at the Instituto Tecnológico Superior Arias Balparda in 2004, a Mercedes-Benz diesel engine was modified to run as a fast combustion engine using gasoline of 55 to 95 octane, without spark plugs and with a compression ratio of 24:1, showing extremely low emissions. Only 0.05% carbon monoxide and 70 parts per million of hydrocarbons, with no nitrogen oxide, far below the strictest international standards. For several years now, a new milestone has been reached: zero emissions. If every engine in Uruguay used MCR technology, we would stop emitting 600,000 tons of CO2 monthly. Despite its enormous potential, the MCR has faced significant bureaucratic obstacles that have prevented its large-scale implementation. This innovative engine was patented, and its information is publicly available on the Ministry of Industry, Energy, and Mining's website. Furthermore, the Association of Inventors of Uruguay, an organization that supports and advocates for the country's inventors, has recognized the importance of the MCR's development and has offered support in various instances. You can find several relevant links, such as interviews and publications, in the video description. Over the years, some critics of the MCR have been mainly those linked to major automotive industries. These industries have attempted unsuccessfully to replicate this engine's design, implicitly acknowledging its technological advantages and disruptive potential while disregarding existing associated patents. Examples such as Mercedes-Benz Diesauto engine, Mazda Skyactiv, and Toyota's Dynamic Force are attempts made by these brands to improve efficiency and reduce emissions in their engines. However, despite significant advances in these technologies, they do not reach the level of zero emissions that the MCR offers. The MCR technology stands out for its ability to operate on any type of fuel, including clean fuels generated from waste, placing it far above conventional engines. Ford's EcoBoost engines and other gasoline direct injection (GDI) engines have reduced emissions and improved efficiency, but they lack the sustainable reach and versatility of the MCR. This implicit recognition these large brands contributed to, along with their failed attempts to replicate the MCR design, highlight the technological revolution that this engine represents and how it challenges traditional business models within the automotive industry. This project has been presented to various organizations, including the Ministry of Industry, Energy, and Mining, the Montevideo City Hall, and international bodies, with the aim of achieving its implementation in decarbonization plans. However, to this day, it continues to face the same obstacles. Stay informed, comment, and share this video. Let's take care of the planet together.